Hello guys, so today I'll show how to create this kind of soda can effects, or you can create this kind of effect in Houdini. So this is my rendered version. Uh, so this is the one layer, this is the one layer, this is the one. So this is for my render version. So I made it in Houdini native clip simulation. So let's jump inside the Houdini and I will show to you how to create this kind of effects. Okay. So go to inside my Houdini. So this is my the file. Okay. Don't worry, I will show to you from the scratch. Okay. So here is the few thing. This is my Shoda can model which I download from the internet. So you can download from the internet. And this is my the source area. Okay, let's jump. Okay, I'll make a new geometry node. Mm, Shoda can fix. Yeah, so we have three things. This is for our source, okay, and this is for our soda can model, and this is my collision, okay. Uh, okay. So we first need these three things. Need a source, and then this is for our can, and this is our collision object, okay. So first of all, this is my soda can, and so I downloaded from the internet. You can download it and you can import your Houdini and you can do this thing. Okay. So first I make a doc network called scene. And to color. Okay. So this is our source. Okay. In the scene dot network, we need to flip object, flip source, solver file, and the gravity node. Okay, yeah, so we are getting like this. So this is we get by default, and there is nothing, it's just falling down. Okay, so first of all we need to change this thing. This is this color thing, this shape. We need some shape like particle shape. So for this thing we can go this guide option. Here's the particle, and this the for visualization you just choose to particle, so our shape is changed. Okay, and it's still falling down. It's falling down because of this domain is the open domain. Okay, so we need the ground plane, or we need the close this backs the lower area. So here is the flip object. You can this close boundaries option, so you can tick this close boundary option, and so yeah, now it's collide with ground. Okay, so first of all we change this source area. We need this source from our source. Okay, so this is our source. Okay, this is our source. So we take a null node and name it out resource. copy and initial data. Here is the shop path need. Okay, so you can paste it here. And whatever is showing nothing. Okay, so because of this, I think we need to some particle separation. Okay, this thing. So you can decrease this particle separation thing. That means you can increase this particle separation. And then after that, I have to change the and select can select clip solver, and this is the volume motion. We can change the bounding. So we can change for the bounding change. You can change from here, or you can select and just select this show handlebar. Okay. So you can see. Okay. So you need collision for this. Okay. So we can change this bound little more. Okay. So for collision, we need. So this is our collider. Okay. This is our collider. So we need a collision source. And this for the geometry. This is out collision geo. The left one always the geometry thing. Okay. And the right one is the VDB thing. So if you see, this is not good. Okay. So for this thing, I just go to the volume tab and decrease the volume voxel size. So I think 0.05. It's not enough. 0.02. Yeah, it's fine. Okay, now it's fine. Okay, this is our collision. This is our source. This is our collider. So collision need static object and a merge node, connect this and this, and here is the need the soft path. So you can go here, and this is our soft path. This is our geometry. Okay, so Control C and the static object. This is can paste it here. This is Control key, and here you need the proxy volume. This need by volume sample, and just copy this VDB, Control C, and you can paste here. This is the proxy volume tab. So you can see this our collision. This is our actual collision. Okay, not this one. Okay, this one for our soft geometry. Hello. Okay. So I think we can customize our bounding. Yeah. Uh, uh, you can see the collider is working fine. Okay, so it's look like very fast. I think you can see very fast. Okay, so I think at this time, this little more. And go to the flip object and just uncheck this close boundary. Okay, so this is too much fast and we have need a more particle. Okay, this is very less particle, so we go in here and 0.05 should be okay. So now we have more particle. Okay. uh, yeah, so should be okay. And oh, so I make one flipbook. This is, I think, the collider is working, but I think this is very fast. For the fluid simulation, we need some the slow mo thing. Okay, if in the fluid sim, if we have a slow mo thing, there is the result is very nice. So for this thing, you can go there. This go to the flip solver, and here is the sub steps, and here is the time scale. You can just decrease the 0.25. So for the particle motion, I just decrease this thing. Okay, so here we got the slow mo thing. This is looking very cool, no? Okay, so here the slow mo thing. Okay, and we need some more particle because there is this is a very less particle. That's why it's so. I just in the flip solver, here is the in the flip object, there is the uh, this thing, collision by collision, no, not this one. Yes, in the volume motion, here is the surface tension. You can enable the surface tension and make 1.5. So surface tension, how it works? So um, maybe- for the surface tension we need some this kind of this line kind of this water thing. Okay, so in the first splash thing we have need some this kind of line thing. Okay, that's why we are enabling the surface tension. Okay. Okay, so I just turn on and just surface tension for 1.5 for this thing, and I just increase here the particle separation. If you have a good machine you can increase lot. Okay, so depending your machine thing. So I have a 64 gig machine, so I have increased your 1.35. You can tweak your according your system. Okay, and I make a one flipbook also. uh, so this is the flipbook simulation I have made with the surface tension 1.2. Okay, so I think it's good for the testing thing. And the final simulation we have done, we can make a little more increase the particle separation, and I can get so this is our the one collision thing. Okay, and this is for enable the surface tension. And one thing I just missing, uh, here is the collision area. You can just by default it's check the plane between the frame, plane between frame. That's why I just turned off. And this is the velocity. I think there is the central difference velocity. You can choose to none. Okay, this is the for the velocity thing. So we do not need the any velocity. Okay, and this is our can. Okay, so I have we get new collision. This is a can. We need can collision also. So I check same thing. Just copy this thing and this is for collision out can VDV can geo. Okay. I think the interior is not done, so I need polyfill for the better collision. Okay, and increase little more. Here, one. Yeah. So this is for our can geo. Control C, and I can need one static object for can collision. And this is for can collision. I can copy paste the geo thing, copy this one, and you can paste it here. Just merge them. Sorry, so, can is here. Ah, collision is proper. Maybe by size. And Japan should be okay. Yes, L for layout thing. And if I Okay, so I make a flipbook done. One second, I just check the flipbook. Copy. So, so this is our flipbook, and this is our flipbook. So this one without can collision, and this one with can collision, which I add later. So I think it's this is for good, uh, for the testing thing. So for the final thing, I just increase little bit the particle separation. Yeah, I think it's good. Okay, so mm, for the caching thing, I think to dot IO. No, for the final thing, you can just I guess increase the 0.03, and here the simulation tab I just increase the substation to okay, and dot IO dot IO dot IO, can just drag and drop, drag and drop, and just copy this thing, click object, and paste this click object. Okay, and oh shit. So this is my the older sim which I have done. So you can take the DOP input full. Okay, so you can take the DOP import field. Okay, and just copy this sim, Control C, and paste it, Control V, and Control C, Control V, take click object. Okay, and you can choose the particle thing. Okay, so you can get this particle. Okay, and you can take a file cache note, and you can set your this folder. So and you can change your name according to sim particles. Okay, and then you can cache that. You can see from where you can your path, your exact path you can see from here. So we have already cached this file. So this is our final particle cache. Okay. Okay. So this is our final particle cache. Okay. And so we need to mesh this thing. How can do that? Okay. So for meshing, you just need VDV from particle, VDV from particle, size 0.02, 0.02. So you can get the particle size and also can reduce this 0.2 and you can reduce this 0.05. Oh, sorry, 0.1. No, you have to default 0.1. Oh, this one 0.05, and after that you need some very smooth. So you can smoothen our particle. You can iteration 3. Okay, now this is now need to convert this surface to polygon. So your convert node, take and just convert from VDB to polygon. Okay, so this is my mesh. Now mesh. You can cast it out. Take a file cache node. Sage water mesh. Water mesh. And you can set folder. Chart. Okay. Then you can just save to dates. Okay, so that's it for the meshing thing. In next video, I will show how to render with the Karma. Okay, in the Solaris. Okay, so thanks for watching, guys.